Math 3, Unit 4, Section 5. Today we're talking about applied problems with rational equations. So we are going to be seeing how rational equations are used in word problems. Okay, here we go. Number 1. You guys ready? Okay, Tristan can type the article or articles for the Cougar Growl in 6 hours. So I'm going to go ahead and highlight Tristan, and Tristan is 6 hours. Okay, then we have Duran, and I'm going to use a different color for Duran. Duran can type the articles for the Cougar Growl in 8 hours. Okay, so we have 2 people working to complete a job. Okay, write an equation that can be used to find the time t. So we're dealing with time t in hours. It would take Tristan and Duran to type the articles for the Cougar Growl together. So they're both working, okay? Sometimes, and if you were like gonna search this on Google to try to find problems that are similar to these are called like work rate problems. So what happens is we have Tristan, and basically it takes him 1/6 t to complete a job. So if he had 6 hours that he was working, you'd have a fraction that would be 6/6, correct? And he would complete the one job. So time being each hour you put in, okay? He's gonna work. Do you guys know what Duran? We're gonna work with Duran now. His would be what, do you think? 1/8 t. Okay, so if he had worked for 8 hours, he would complete the one job. You get 8/8, reduce this to one job. And so these are going to equal together. We're going to find the answer, and it's one job. So whenever we're doing these work rate problems, you're dealing with the time of each individual, and they're going to complete one job. Okay? So what would we do to solve this based on everything we've been using this unit? We could find like denominators. When we were solving problems though back in unit or section 4, we eliminated the fractions by finding the LCD. Do you guys remember that? Okay, so let's do that. Do you guys know what the least common denominator for this problem would be? So we could use 48. Can anyone think of something smaller just so we have smaller numbers? 24. So you could use 24 or 48, it doesn't matter. Do we have any extraneous solutions on this? Are there any variables in the denominators? No, so there's none. Okay, or you could write none. Okay, so now we're gonna solve for t for this problem. So I'm just gonna rewrite the problem here. Do you guys wanna put the t on top, or do you just wanna keep it to the side like that? On top. So we can rewrite this as t/6 plus t/8 equals 1. And then to solve this, we would multiply every single term by our LCD. And in this case, what value again was that? 24. So next to every single term, I am writing a times 24. And then we're going to reduce. So 6 goes into 24 how many times? 4. Good. And 4 times t is? Good. 14. Okay, and then the next one? 3. Good. Reduces to 3, and so we have 3t. And last 1 times 24 is just? 24. Good. And then we will solve by combining like terms. So we get 7t equals 24, and the last thing we will do is divide by 7. So the time it takes is 24/7 hours. Now, do you normally say time like that, 24/7 hours? No. So what do you think we should actually do?
Fraction or decimal?
Yeah, you could change it into a decimal or just divide 7 into 24, right? So if 7 goes into 24, how many times? 3, and then that is 21, and we subtract, and there are 3 left over. So this seems a little bit more appropriate, which would be 3 3/7 of an hour is how long it will take them to complete the job. Do we have any questions? Now, if you put 24/7 of an hour or whatever on your test, do you think I'll mark it wrong? No. It just makes more sense this way when we're talking about time. Okay, but either is okay. All right, we're moving on to the next one. A group of friends decides to rent a bus to take to Magic Mountain that costs $400 and to divide the cost evenly among the friends. Initially, there are X friends, but then 4 more friends decide to join the group, causing each friend to pay 5 less. Create an equation that represents the situation and can be used to solve for X, which is the initial number of friends. Okay, so let's think about it. If, for example, there were 400 friends, or sorry, not 400 friends, 10 friends, how would you figure out how much to pay each person? You would do 400 by 10. So originally, with our original value, it would be 400 divided by X. Do you guys agree? Okay. So whenever you're writing equations, you always are balancing them so that they would end up being equal on each side of the equation. Okay, so we know there's going to be an equal sign. Okay, and then we have another equation where something happens and people add and it costs us less money. Okay, so what do you think part of the equation will be on the other side for when more friends add? The bus still costs $400, correct? Okay, so it's still going to have a 400 divided by, but there's no longer X friends, there's X plus 4 friends. Is everybody okay with that? Yeah. Okay. Now this is where, see right now, these equations are not balanced because one's divided by X, one's divided by X plus 4, and that's not going to give you the same totals. Do you guys agree? Okay, so that's where this comes in. That is going to help us balance the equation. So, if you want, what do you guys think we're going to do with that? So let's think about this. Let's go back to my example of 10 people, okay? So we're just gonna do a little side note. So if I had 400 divided by 10, we all agree that that value is what? 40, okay? And so over here, if I'm using 10 still for X, if I did 400 divided by 10 plus 4, that's really 400 divided by 14, and I'm just going to get a calculator out here really quick, or try to if somebody else. Okay, 400 divided by 14 is 28.6. And so based on that, okay, so looking at those numbers, if I subtracted 5 from this side, that would make this value even smaller. Do you guys agree? So would subtracting 5 over here make sense? No. In order to balance it out, what should I do? You subtract 5 from this side because that would end up making it so it's balancing out. Okay, the other option you would have is instead of subtracting 5 on this side, you could add 5 on this side. But since it's saying pay less, I feel like you guys would rather do the subtracting 5. And so in order to balance it, you would have to subtract 5 from this side. Does that make sense? Because right now this one is more, and so in order to make it balance, we'd need to make that side less. Yes? Okay, so we're going to write here minus 5. Okay, we've created our equation. Now what are we going to do to solve it? Just similar to the previous problem, what should we find when we have these? LCD. And you might even, so I'm going to rewrite this problem. So we have 400 over X minus, I'm going to put 5 over 1 so I can see that it's also a fraction there, equals 400 over X plus 4. Okay, so we need to find our LCD and also if there are any extraneous solutions. What will be my LCD for this problem? Well done. X times x plus 4. So remember, if there's anything that has pluses or minuses, we put parentheses around it to remind us that that whole piece is stuck together and it's separate. It's totally different than a plain x, right? Oops, and I forgot this parenthesis. Okay, and based on that information, what would be my extraneous solutions? -4, and what else? 0. Because you had set each of those LCD, each of those factors equal to 0, and so that would be x equals 0, and when you set x plus 4 equal to 0, we get a -4. Any questions before moving on? Okay, what would I do now? Well, because we have the equal to sign, so this is different. So when we're solving equations and we have this equal sign, we can always eliminate fractions. We don't have to get like denominators. So anytime we have the equal sign, we can eliminate fractions and solve. If we don't have an equal sign, then we have to get like denominators and add. Does that make sense? Okay, so that means that for every single term here, I'm going to multiply it by my LCD. So next to this first one, I have x times x plus 4. Next to the 5, we have x times x plus 4. And next to this last fraction, we have x times x plus 4. Okay, so on the first problem, and I'm not going to distribute anything right now because I want to make sure we get everything correct. What can eliminate first in this first fraction? The x's, good. And so we're going to just write this out right now. 400 times x plus 4. Okay, can anything eliminate in this fraction? No. So I'm going to write this as minus 5x, because the 5 and the x can multiply together there, times x plus 4. And we're going to go back and distribute here in a minute. And then what happens on the last fraction?
The x plus 4 cancels out.
Good. The x plus 4's cancel out, and we are left with 400x. Okay, so now we want to solve for x, so we're going to start by simplifying. Okay, and so we will distribute, and 400 times x is 400x. 400 times 4 is, good. Minus 5 times x is minus 5x squared, good. Minus 5x times 4 is negative 20x equals 400x. Now, while these are big numbers, you guys are capable of solving this. Notice that there's an x squared. Do we see that? So anytime there is an x squared value, we're going to have to end up factoring or using the quadratic formula if necessary. Okay? But in order to use that, to factor or use the quadratic formula, there's a couple things that we need to make sure we do. And what is that?
That the x squared is positive.
X squared needs to be positive, and what else? Combine like terms, and the equation has to be set equal to 0. Okay, so if you don't remember those things, maybe we should write them down right here. So let's just put like a little side note. When factoring, squared term needs to be positive. Bless you. Okay. What is the other thing we need to do? Combine like terms. And what was the third thing? Very good. Set equation equal to 0. Okay, so based on all of this, what should I do?
Subtract 400x.
Yeah, so we can go ahead and subtract 400x, so that way we can get it set equal to 0, and then could I just like divide by -1 and change all my signs? Okay, so let's go ahead and do that. We are going to subtract 400x, and I'm going to subtract it with the like term over here, and what do you notice happens?
They cancel out.
They cancel out. If you ever have the same exact term on both sides of that equal sign, they'll end up canceling out. Okay, and so now let's rewrite this in descending order. How should I write that?
Negative 5x squared.
Negative 5x squared
Minus 20x.
minus 20x
Plus 1600.
plus 1600 equals, good, equals 0. All right, everybody okay with that? Okay, so we're going to divide by negative 1 in order to change the signs, but we could actually, do you guys see a GCF here? Negative 5. So we can just go ahead and take out a negative 5. Is that okay? Or if you want to change all the signs, you can, but if I divide by negative 5, I'm going to change all the signs as well. Okay, so we're factoring out a negative 5, and when I do that, I'm dividing every single term by my GCF, which is negative 5, and I end up with what? Good, positive x squared. Very good, positive 4x, and this last one's going to be minus, good job, 320 equals 0. Okay, is my squared term positive now? Yes. Did I combine like terms? Yes. Did the equation get set equal to 0? Okay, perfect. Now I can factor. Okay, so what do I do to factor this one?
Multiply to negative 320.
So we're going to multiply, right? So my multiplication number is negative 320, and my adding number is what? 4. Okay, now we're like, oh my gosh, 320, and some of you are probably like, I don't even want to start. But you can. It'll be okay. Okay. So we could always start with 1 and 320 and start going down, but we're going to need bigger numbers in order to subtract them to make a 4. Does that make sense? Okay. So if I have like 32 and 10, when I subtract that, it is 22. Not helpful, right? Okay, can you guys think of other two numbers that are easy to think of that multiply to be 320?
40 and 16.
Okay, so I heard 80 and 4, but that's not going to work. And then you said 20 and 16. Does that make 4? Yes. And if we needed to, could we start at 1 and go all the way down? Yes. And you could end up finding the answer. You guys are all capable. Okay, so, but with these numbers, which one has to be positive and negative?
The 16 has to be positive and negative.
Good. 16 has to be negative in order for these to subtract to make a positive 4. And then they multiply to make the negative 320. Can I use my shortcut? Yes. So we have negative 5, and then I make my parentheses. Because this is an x squared, we get a what in the front of each of the x parentheses? An x, right? So whatever your like term is there, or whatever your term is there in the front, you're splitting it up. So if it was x to the 4th, I'd end up with what here? X squared. Since it's x squared, they each get an x. Okay, and then I have a plus 20 and a minus 16, and this is set equal to 0. Now what do I do? Exactly, set each of them equal to 0. When we set negative 5 equal to 0, does that make sense?
No.
Nope, that is not an answer. When I set x plus 20 equal to 0, what do I get?
Negative 20.
Negative 20. Can I have negative people? X represents people. No, we can't have negative people. Even though people are negative, it's not an actual person, isn't it? Okay. All right, and then last we have x equals 16. Is 16 an extraneous solution? No. What was our extraneous solutions? Good. So that means that there are, in the initial value, x equals 16 what? People. And make sure you label your answers. I know, it's a lot. Good thing you guys have like cell phones and stuff to keep track of each other. Okay, all right, moving on. We are going to do one more problem, or no, just kidding, 2 more problems. Okay. Boyles Law states that the pressure P of a gas is inversely proportional to the volume V of the gas if the temperature remains constant. This results in this equation, P equals K divided by V, where K represents the proportionality constant And they just want us to solve this equation for v. They say a lot of information. They want you to just get v by itself. Okay, we're going to write the equation. P equals K over V. Just like we've done with all of our other problems, what is the LCD? V. We can put P over 1. The LCD is just V. Yes? Okay, so because we have an equal to sign, and I'm just going to highlight that here, we can eliminate our fractions. And so I'm going to do what? Very good. Multiply V to every fraction. So what happens on that first, on the left side? We multiply them together. Normally with letters, when you multiply them, we write them in alphabetical order. So that means I would write that as PV equals, here the V's cancel out and I'm left with K. Now, again, and you might want to make sure that this is like highlighted. Always look back at what the question is. It says to solve the equation for V. How do I get V by itself? What do I need to do next? Good. Divide by P to both sides. And so my answer is V equals K divided by P. Is that okay? We're almost done. Okay. Consider these rational equations right here. Solve this equation for H. So again, we want to make sure we are aware of what we're solving for. Okay? We have our equation right here, and I'm going to rewrite it. And whenever we have an equal to sign, we know we can do what? Find the LCD, and then we end up eliminating our fractions. So looking at this problem, what is my LCD? Good, and I'm going to write that in alphabetical order. So I'm just going to write that as A, B, H. Does anybody have questions right now? Okay, so now what do I do with my LCD? Multiply to every single term. A, B, H, A, B, H, and A, B, H. The first fraction, what happens?
The H cancels out.
Very good. The H's eliminate, and we're left with AB times 1, which is just AB. Good. Equals. The next fraction, what happens? The A's cancel out, and we're left with 3 times BH, which is 3BH. We have minus, and then the next one, what happens? And we're left with 2AH. Okay, so now that we've eliminated the fractions, let's go back and recall what they're asking us to solve for. And it's H. How are we going to get H by itself? Do you guys see right now how all the H's are on the right side of the equation? Mm-hmm. Okay, is there some, do they both have H in common? Yeah. How could I end up making them so that they're like 1H? Because right now I can't add or subtract because they're not like terms. Very good. Factor out an H. Good job. Divide. Yeah. Okay. So each of these have an H in common, correct? Yeah. And so what I'm going to do is I'm going to factor out that H because then it will be just 1H. Oops, what am I doing? So I'm dividing each of these by H. Do you guys agree? Mm-hmm. And so what am I left with when I do that?
3B minus 2A.
3B minus 2A in parentheses. And then I still have AB over here on the left. What am I going to do now in order to get that H by itself? Good. Divide by 3B minus 2A to both sides. These eliminate, and that's my answer. H equals AB over 3B minus 2A. Any questions?